All right. So I'm audible right now, right? All right. So we are live right now. Great. So welcome back. Welcome back to this amazing platform of Tutee learning. So myself Sirsha Banerjee, and I will be the maths mentor for this particular discussion. Okay. So let's start. So welcome back to this particular course, and we have been discussing over vector algebra for the past couple of days, right? So if you have been following this particular channel for a long time, you must have seen that we already finished the calculus portion, especially for JEE Mains and Advanced, right? So this particular lecture series is going to help all those who are preparing for the upcoming JEE Mains and Advanced paper, right? So for 2026, if you're someone who is preparing for the JEE Mains and Advanced, this particular lecture series is going to help you a lot. All right. So with this part, let's get started, right? And if you are new to this particular platform, again, I would request all of you to please subscribe to the channel and also hit the bell icon so that whenever we are live, you definitely get a live notification, right? So you will definitely have a chance to study directly from me and ask your doubts and clear your doubts also from me, right? All right. So please share this particular video with your friends and your relatives or your juniors. Cute and polish. Hello. All right. So with this, let's start. Right. So as of the last session, we have been discussing so far over the basics of vectors. And along with that, we discussed over the properties or vector addition and subtraction and certain properties regarding vector addition and subtraction, right? Now, along with that, we have also discussed about one more important thing, that was multiplication of vectors by some scalars, right? So this is all what we have already finished in our previous class, right? So in today's session, I'm going to discuss about certain more important topics regarding collinearity, regarding coplanarity, and then we're going to solve certain general basic questions from JEE Mains and Advanced. All right. So that will be the entire content of today's particular lecture. All right. So with this, let's start. Now, as of the last class, we finished solving this particular problem, right? So today, let's try to understand about another important thing, that is position vector, right? Now, we have already talked about we have already talked about position vector, right? Now, if you recall, as the end of the last class, I mentioned that today we're going to discuss about that how vectorically we are going to represent all the important points in the triangle, right? So, for that, let's try to understand the position vector once again. So if you recall my previous discussion, so if I have my coordinate axis like this, if this is my x, this is my y, and this is my z axis like this over here. So any point on this particular coordinate axis will definitely have this ordered pair or tuple, that is x comma y comma z, right? Now if I join the origin with this particular point P, and the vector I obtained by joining this particular point P with the origin is therefore referred as the position vector. Okay, so the position vector is nothing but it is a vector which is connecting that particular point and the origin, right? So position vector is a vector which connects the origin to that particular point in the coordinate axis, right? So that is what we have discussed about in our previous understanding, right? Today, we're going to learn about that how am I going to represent the position vector for any point which is basically divided in a section formula, right? So let us try to understand the section formula for vectors. So the first result that I'm going to talk about will be section formula, right? So section formula is a interesting formula, especially in coordinate geometry, right? So if I have, let us say, I have 2 points. Let us say I have 2 points A and B, and I want to find out a point which is intersecting, which is basically dividing or bisecting this particular line segment AB internally. Now, please note that there are two formulas for line segment, right? Where the the point which divides the line segment may lie on the line segment or maybe somewhere outside as well, right? So based on the outside and the internal or external presence of this point, we can definitely have two different formulas, right? So I'm going to discuss first with the internal division. Okay, so let us discuss about the internal division, right? So let us talk about the internal division, right? So what I'm trying to say is that let us try to draw the coordinate frame. So let me do with the 2D analysis, okay? So that you can and you can definitely extrapolate to that of the 3D coordinate as well, right? So if I start with, let us say I have point A over here and my point B over here. So let us name this point or let us give the coordinate x1 y1 and B point as x2 y2, right? All right. Now if I ask you this question, now I already mentioned, and now you are in a better position to answer me that if I have the position vector, so instead of giving me the if I even if I have the coordinates, and with the coordinates I can definitely obtain the position vector. So if I ask you that what is the position vector of A, so let us call this position vector of A as small a. Generally we represent position vector with a small quantity, small letters, right? And similarly the position vector of B is given by small b. So if I ask you that what is the position vector of A, you will be telling me the answer as x minus 0 I cap plus y minus 0 k cap, sorry, j cap, right? J cap, right? So this is fairly from the taken from the basic understanding of the position vector, because we have learned in position vector that any vector can be given as final minus initial, right? So if I just subtract the final from the initial, then only I'm going to get to the vector, or I'm able to write the vector for that particular line segment, right? So if I do that over here, so similarly vector A can be given as x minus 0 I cap plus y minus 0 j cap, which is nothing but, so it should be x1 and y1, sorry. So it should be nothing but x1 I cap and y1 j cap, right? So I will have my A vector. So I will have my A vector as follows over here, right? So I will have my A vector as follows over here. Now similar result, I can also obtain my position vector B as x2 I cap plus y2 j cap, right? So similar manner, we can also obtain my B vector. So I have obtained the position vector A and the position vector B, right? Now if I ask you another question, that if you consider this particular triangle, in the triangle AOB, if I ask you to apply the triangle law of vector addition, what you will obtain is that if I add A vector plus this AB vector, okay, plus this AB vector, that will generate me the result of B vector, right? So this is from the triangle law of vector addition. So this is taken from the triangle law of vector addition. All right. So I hope you recall the previous lectures, right? Triangle law of vector addition, right? Triangle law of vector addition. All right. So this is from the triangle law of vector addition, right? So once I write this expression, what I observe is that this particular vector AB can be written as B vector minus A vector, right? So it is very obvious as saying that what we have learned in position vector is that we write the position vector in terms of the final minus initial. So over here, if you note that the position vector of point A and point B are given as A vector and small a vector and small b vector, in this case, I can find the vector AB. So I can find the vector AB as position vector B minus position vector A, because that is final minus initial, right? So we will have this as my AB vector. So we will have this as the AB vector, right? So this is a way to write the AB vector, right? But our main idea is not to understand or how to write this E vector. However, we are going to analyze the result of section formula. Now let us come back to that particular coordinate geometry, right? So if I have this same thing over here as x1 y1 and x2 y2, and if I ask you that, let us say the C point is an internal division of this line segment AB, which is dividing the line segment in the ratio. So the ratio is m is to 1. So it is dividing the line segment AB in the ratio m is to n, right? So if I want to write the coordinate of the point C, which is dividing the line segment AB in the ratio m is to n, how am I going to write this coordinate? So I can easily write this coordinate of C as m times of x2 plus n times of x1 divided by m plus n as the x coordinate, and similarly the y coordinate can be written as m times of y2 plus n times of y1 upon m plus n. So this will generate me the result of the coordinate of point C, which is dividing the line segment AB in the ratio m is to n, right? So this is a simple result that we have already learned, and we have derived this particular result in our coordinate geometry. So if you have finished or studied about coordinate geometry, which is basically your class 11th or maybe in your class 10th also, right? So you must have seen this particular expression, right? And we can easily derive this expression by help of some geometry relations, right? So you can also try to get to the proof of this particular result as well, right? So what I understand is that I get the internal division formula something like this, right? Now instead, let us say I don't have the coordinates of A and B, but I have the directly given as the position vector of point A and position vector of point B as A vector and B vector respectively. Now, does this particular formula also applies to that case of a vector, position vector, is that we are trying to explore over here. So yes, it definitely acts over here. And in this case, I can find out the position vector of point C as small c. Now the result for internal division is basically very simple. That is m times of b vector plus n times of a vector whole divided by m plus n. Okay, so this is the position vector for point C, or the point C which is dividing the line segment AB in the ratio m is to n. So this is how I'm going to relate this particular result of section formula for coordinate geometry to that of the position vector for vectors, right? Now if you ask me this question that how am I going to write this expression, again, very simple, that you must have applied that in a geometry classes of triangles, that if I have a triangle like this, let us say we have any triangle, let us say this is our any triangle ABC, which has nothing to do with this point ABC over here, right? So if I say it's our general triangle, now if I drop any line which cuts this particular side in the ratio m is to n, then there is a result which relates, that is AB upon AC. uh, So, uh, yeah, so there is a result to relate this particular line segment AB and AC with BD and DC, right? So there is a one particular property, so with which you can relate to that particular result, right? All right. So generally it is basically given as AB upon AC, which is basically equals to BD upon DC, and which is nothing up by M upon N. Okay, which is simply as N upon M. So you can use this particular property to derive the section formula, right? So if you recall the classes of derivation of section formula in your in your junior classes, maybe class 10th or maybe class 11th or just a year ago. So you must have recall that you have derived the expression for this section formula in this following manner. Okay, is this part clear to all of you? Is this part clear to all of you? Is this part clear? Right. So from here, you can get to the internal division. Okay. So from here, you can get to the internal division. However, that if I ask you this particular problem, we have already seen this kind of problem in our coordinate geometry, that if my line segment AB is there over here, but I am taking a point C which divides this particular line segment externally in the ratio m is to n, where these are the following ratios, right? So I hope if you understand this particular part. So from here, this is basically nothing but known as the external division. Okay, so this is known as the external division. So if you recall, the point C can be given as m times of x2 minus n times of x1 upon m minus n, comma. So the coordinate of point C is given something like this: m times of y2 minus n times of y1 upon m minus n. So this is the result for getting the coordinate of the point C, which is an external division of the line segment AB in the ratio m is to n. Right. I hope so. From here, the similar results for the vector position vector can be obtained. Let us say this is the position vector A and B, and the position vector of point C is C. So the position vector of point C for external division can be similarly obtained as m times of B vector minus m times of A vector. Oh, sorry, n times of A vector divided by m minus n. Okay, now over here the only thing to note is that m should not be equal to n, right? So only thing to note is that m should not be equal to m. Even if m is equal to n, that such point will be an irrelevant point, right? It's not a real point, right? So you can see over here that m should not be equal to m, otherwise it won't exist. Okay, otherwise this particular concept won't exist. All right. Alright, so this is the simple result for external division of a line segment. Okay, so from here we can also relate the expression for midpoint theorem or midpoint formula, right? So if I have any particular line where the ends of the line is basically given by point A and point B, where this is my position vector A and this is my position vector B. So in this case, if I want to find out the position vector of the midpoint, if I want to point the position vector of the midpoint, that is C, so the C point can be simply obtained by putting A and B equals to 1. So that is basically A vector plus B vector upon 2. So A vector plus B vector upon 2. All right. So this is the midpoint. So this is the midpoint result. Okay. So this is the midpoint result. So from here you can obtain in the midpoint of a given line segment. I hope this discussion is clear to all of you. Is this discussion clear? Sudha, say it again, please. Which part do you want to repeat? Which part do you want me to repeat? Please let me know which part you want me to repeat. M not equals to n. Okay, so m is not equal to, so if you see over here in the denominator term over here, you can see that m minus n term is happening, right? So if my m is equals to n, then this particular thing will be division by 0, and division by 0 is not defined, right? So anything divided by 0 is not defined, so therefore m should not be equal to n, right? Is this clear, Sudha? All right. So this is the result for the finding of the position vector of any point on that particular vector or the line segment that is basically divided by certain ratios. Okay. I hope this is clear to all of you. And with this, you can also get the expression. So if I have a triangle, so let us say I have a triangle. So let us say I have a triangle whose coordinates are given as A, B, and C. So let us say I have a triangle whose coordinates are given as A, B, and C, and I want to find out the centroid. So centroid is nothing but the intersection of the medians, right? So if I try to find out the centroid, this is my centroid, which I am representing by G. All right. So if I try to find out my centroid, and let us say the position vector of A, B is given by this following vectors as A vector, B vector, and C vector respectively, right? So if I want to find out the centroid of this particular, or the position vector of centroid, so in this case the position vector of the centroid, okay, the position vector of the centroid can be simply given as A vector plus B vector plus C vector whole divided by 3, right? So this is simply from the results that you have in your coordinate geometry. So you can see that certain results of coordinate geometry is going to be the similar over here, right? So I'm just going to take up those particular results over here. Also, if I take a 4 points and make a tetrahedron, so if I take a 4 points and make a tetrahedron, so if I make a tetrahedron over here, let us say this is point A, B, C, and D, where my position vectors are given as A vector, B vector, C vector, and D vector over here. So in this case, even if I want to find out the centroid, even if I want to find out the centroid, okay, if I want to find the position vector of the centroid, then that can also be given as A vector plus B vector plus C vector plus D vector whole divided by 4. Alright, so the position vector of this centroid of a tetrahedron, so position vector of a centroid of a tetrahedron can be simply given by sum of all the position vector of the points or the coordinates divided by 4. Alright, so these are the two important results that you need to relate to while you are also going to solve questions. Okay, so I hope this part is clear to all of you. Is this part clear? Can you give a short note for this chapter? Yes, Sudha, I will definitely give the short note, but first let me finish the chapter. Okay, so let me first finish the chapter, and once the chapter is finished, I am definitely going to bring short notes. Okay, and I'm also going to bring in one shot lectures. Okay, so once we are near to our JEE mains examination, I'm definitely going to take up or carry out the revision lectures or one shot lectures. Okay, so don't worry on that. Okay, the only thing that you need to do is subscribe the channel and keep following the channel as it is. Okay, so whatever we are covering here, please follow the channel, and whatever homework we are giving to all of you, please try to solve those homework. Okay, so even if you do that particular bare minimum effort, you can definitely be able to clear the JEE mains and advanced examination. Okay, is that clear to all of you? Is that clear? And also, if you still think that you have a doubt that whether you are able to finish that particular chapter or not, or you still have some backlogs and you want to finish that backlog by sitting in a one-on-one online lectures, okay, so definitely you can contact us on our given number that is given in the description box as well as in the live chat. So you can check out the live chat as well, and also in the description box. Okay, so please contact us on that particular number, so that whenever you need some help or you want mentorship or you are stuck in some problems, you can definitely contact me on that particular number, so that I can help you out with that particular thing. Also, we have started our short courses on backlog clearing sessions. Okay, art zone, hi art zone. All right, so backlog clearing session has also been initiated. All right, so if you want to get access to that particular backlog clearing classes, okay, and you want to study from those particular lectures, you can definitely contact me on the number and you can get live access to that particular backlog classes. Okay, so whatever is your backlog, you can contact us on that particular number, so that I can help you with your backlog clearance. Okay, so let's start discussing about another important topic, that is called as linear combination of vectors. Okay, so let us try to understand the linear combination of vectors. So what this actually mean by linear combination of vectors, let's try to understand. Okay, so linear combination of vectors, so as the word suggests, it's a linear combination of vector, means a vector can be linearly expressed in terms of certain n number of vectors. That's the basic idea. So what I'm trying to say is that if, so in linear combination, I will try to say that if there is an r vector and it is said to be, okay, and it is said to be linear linear combination, and it is said to be a linear combination of of the following vectors, like let us take a1 vector, let us take a2 vector, and so on up to an vector. So let us say I have this r vector which is said to be a linear combination, of this n following vectors, right? So in this case, what does this particular thing means or refer to is that I can express my r vector as some x times of a1 vector plus some, so let us say x1 times of a1 vector plus some x2 times of a2 vector, and so on up to some xn times of an vector. Okay, so where x1, x2, and x3 and so on up to xn are basically nothing but scalars. Okay, so x1, x2, so they are real scalars. Okay, so they are real scalars. So I hope you can follow from this. All right. So these are the scalar quantities. Therefore, if I basically refer to a linear combination of any vector, then it of n number of vectors, then it can be written something like this. Okay. So all the summation or linear combination of this particular vectors can be written over here. Right. So this is basically known as the linear combination of vectors. I hope this part is clear. Right. So this is the linear combination of vectors. Right. So let's now try to understand that based on this linear combination of vectors, how am I going to represent something which is known as collinear or non-collinear vector, right? So we have already discussed about in our basics of the vectors, we have discussed about a collinear and non-collinear vectors, right? So if I try to talk about, so if I try to talk about collinear, collinear and non-collinear vectors, non-collinear vectors. All right. So if I talk about linear and non-collinear vectors, then I can write that in also in terms of, or I can express. So collinear vectors can be expressed in terms of a linear combination. So if I have, let us say I have two vectors which are collinear. So let us say I have a vector and b vector which are given to us as collinear, right? Now, if I recall that what is the basic definition of collinearity? So collinearity means that if I have 2 points which are collinear, that will definitely lie on the same straight line. Similarly, if I have two vectors which are collinear, that is definitely going to lie on the same on each other and is going to have the same direction, right? So if I talk about and says that, then let us say A and B vector are two collinear vectors, and let us say the x cap denotes denotes a unit vector in a vector. Okay, so if I say that x cap denote a unit vector of a vector. Okay, so for a vector, if x cap denotes the unit vector, this unit vector is basically done to represent the direction. Okay, so this is representing the direction. So this is representing the direction of a vector, right? So x cap denotes the direction of a vector. Then by the simple understanding of collinearity, what I can say that the b vector must be either in the positive x cap direction or maybe in the negative x cap direction, right? So therefore, according to this particular theorem, that is a vector and b vector may be like vector or maybe unlike vector. However, they are collinear, right? So therefore, I first of all I can write a vector as mod of a vector into x cap, right? So x cap denotes direction, and similarly I can denote b vector as some plus or minus mod of b vector into x cap, right? Is this part clear? Now from here, if I try to replace, so from here, if I try to write my a vector, so from this particular relations, if I want to write the a vector in terms of b vector, what I can write is that I can write x cap as b vector upon mod of b. So if I just put it over here, then I can write as mod of a vector into b vector divided by mod of b vector, right? And please note there is a plus or minus sign over here. Right. Now this can be combined and the a vector can be written as, so if I take the scalar part as a scalar multiple, so mod of a upon mod of b, so mod of a upon mod of b becomes a scalar over here and multiplied with the b vector. So therefore what I observe is that I am able to write the expression of a vector in terms of b vector. So my expression for a vector can be given as some lambda times of b vector, where this lambda is nothing but a real constant. So lambda is a real number. So what I observe is that if I have the collinear vectors as a vector and b vector, then to represent the relation between the collinear vectors, I can simply use this particular relation, that is a vector is some lambda times of this b vector, which denotes that it is a collinear vector, right? However, if the vector is not collinear, then there won't exist this kind of relations. Okay, so for non-collinear vectors, there is no such relations. All right, I hope this point is clear to all of you. So this is basically it also. Now, one more thing to also understand is that even if you have 3 points and you want to check the collinearity of the 3 points, you can also do that by simply by simply thinking of the collinear thing is that if I have these 3 points, let us say point A, point B, and point C, and I see this particular 3 points are present, collinearity can also be given as, by finding the area of the triangle ABC and then is equals to 0. So the area of triangle ABC equals to 0 also refer to the collinear points, right? So this can also be a way to represent this, right? And in coordinate geometry, you must have derived the expression. So if I have these points as x1, y1 and x2, y2 and x3, y3 respectively for A, B and C, then if I want to say that whether these 3 points are collinear points or not, so the test for collinearity is just to make the area of this triangle equal to 0. So that was basically final conclusion was coming out as something x1, y1, 1, x2, y2, 1 and x3, y3, 1, and then the determinant and mod of the determinant is equals to 0, or maybe just the determinant equal to 0. So if I'm able to satisfy this particular criteria, then the points are collinear. So this is my collinearity test, right? So we have already seen that in our coordinate geometry. So this is a collinearity test. All right. So the test for collinearity is simply by taking this determinant and equate it to 0. I hope this is clear to all of you. I hope this result is clear. Is this part clear to all of you? Give some example. Where is the number, sir? The number is basically in the description box. Okay. Can you give an example for linear combination of vector? Well, linear combination of vector is just simple example, can be a collinear vector. Okay. So collinear vector can be a simple example of linear combination of vector. Okay. I hope this is clear. Is this part clear to all of you? Is this part clear? All right. So I assume this particular part is clear. So with this, we are done discussing about the important properties regarding vector addition and vector subtraction, right? So in my next class, we are going to discuss about another important property regarding the vector dependence and independence theorem. Okay. So in the next class, we're going to start discussing about the coplanarity condition of vectors, or what is the condition that when two vectors are lying on the same plane. So what are the coplanarity condition of 3 vectors, or what is the coplanarity condition of 4 points? We're going to discuss that in our next class or upcoming session. Okay, that is going to be happening tomorrow. And with that, we will be discussing with the linear dependence and linear independence of vector. However, that is not that important, but theoretical or conceptualized wise, it is going to be really important. Okay, so we need to understand all the concepts. So depending upon that particular thing, then we will be in a position to discuss about the some of the standard question. Okay, so what I will try to do is that in the next class, after we've done with this particular part, I'm definitely going to bring the JEE Mains problems that has been asked so far on the basics of the vectors. Okay, especially relating the topics of the triangle geometry. Okay, so with this particular thing, I would conclude the session over here, and I thank you for all of your lovely attendance, and I wish to see you up in our next discussion. Okay. All right, Sudha. So I hope to see you up in our next class. Okay. So please subscribe to the class, subscribe to the channel, and hit the bell icon. Okay. Sudha, please hit the bell icon so that whenever we are live, I cannot confirm the time depending upon the classes or whatever is going to happen. Okay. But definitely that lecture is going to happen tomorrow. Okay. And maybe in the morning time or maybe in the night time. Okay. So out of these 2 times, the lectures is definitely going to happen. All right, so you can see that generally whenever the lecture is going to happen, and if you have clicked on the bell icon, you definitely get a live notification. So whenever we are live, you get a notification, and that particular thing implies that you have to attend the lecture. Okay. All right, and since you were asking about the number, so I can show you the number over here. So let me show you the number. So all right, so let me write the number down over here. I think I don't have in my notes. So the number is basically, so if you have any confusion, any doubts, and you want to get access to live lectures, please contact us on this number. Okay, 850927963. Okay, so please contact us on this particular number. I hope this is clear. Right. So you want to get access to the live batches, please contact us on this number. so as to get this all the materials, all the discussions or doubt clearance or specialist mentorship, okay, or how to clear IIT JEE examination and how to come to IIT. Okay, so all these things we're going to discuss tomorrow, and already done it. Great. All right, so bye bye.